Hi, in this video I would like to share a shell scripting solution that I've recently implemented, which allows you to do something similar to printf, where you have a format string with placeholders that get replaced with the values that you pass to the command. But in this case you can have named placeholders with some additional functionality that allows you to do a few interesting things that you wouldn't be able to do with printf. So let me start with a small demonstration. So the tool is called fstr, or I just say fstring, and you might have some ideas as to where this idea for this name came from, but we'll get back to that later. So let's take a look at a quick example. So the first argument is kind of similar to printf's format string. It is a string with placeholders. So I'll just put here the quick brown, and then instead of saying fox, I'll put a placeholder in. So the placeholders start with the %sign, and then the name can be any number of uppercase letters, lowercase letters, digits 0 to 9, or an underscore. So those are the allowed characters in placeholder names. So in this case I'll just use call it animal, and that's going to be our format string. And then as the following arguments, you pass a name and a replacement, and then a name, a replacement, etc. So any number of names with replacements. So let's pass the name that we've used, so that was animal, and let's put fox as the value, and then when I press enter we get the output, the quick brown fox. So this placeholder was substituted. So this is kind of the most basic functionality of this utility, but there's quite a bit more to it, and so let's take a look at some of the additional things that it can do that are unique to it. So for example, if a placeholder is not defined like this, if I ran it like this, I would get an error and would say that it's unable to replace this placeholder animal. But but I could give it a fallback value, so I can use the curly braces around any placeholder name. So this first way of setting a name was just kind of a shortcut, basically like a shorthand way without the curly braces. You can use the curly braces. I can also add some stuff here in addition to the name. So I can use a colon, and then I can add a minus sign followed by another string with placeholders. So you can even have placeholders in this string, but we'll come back to that in a moment. Let's just use just a string of characters here for this example. So if I run this now it substitutes fox when it sees that we don't have a value for this. So this is kind of inspired by bash with its parameter expansions. So there's kind of this parameter expansion which allows you to have like a default substituted if a variable is not set. So this is kind of analogous to that. So but now if I actually define a set a value for that placeholder, so I'll put animal, and let me use some other value here, let's say rabbit, and now it will say the quick brown rabbit, but it still has the fox as a fallback in case this is not defined. So so this is one kind of interesting thing that it can do. So let's now I guess since I already jumped to this page over here, let me just kind of mention a few things about these pages that I have open over here. So the first one is the GitHub page for this project. It just has everything that you need to download it and use it. So this is kind of all there is to this page. Then I also have some other pages open here, which basically is to just kind of talk about the sources of inspiration for this tool And yeah, basically there's like in Python and in JavaScript there's something that is called so in Python you have f strings, which is basically kind of where I get the idea for the name for this tool, and in JavaScript you have um, template literals, which allow you to put an expression like this in a string, and then that expression will get evaluated, and you get a string with that thing substituted in there. And kind of in Bash, you also have basically something similar where you can have like a string with double quotes, which can which accepts like variable values here, or like uh, command substitutions, etc. So like I could set like a equal to 1, and I could set have a string here and say like my value is $a, and then it will give me my value is 1. And I could also have uh, like a command here, kind of analogous to an expression in Python or JavaScript. So like I could say like another echo like 1 whatever, and I get my value as 1 again, as well. So there's kind of, this is like analogous functionality in Bash to these two things in JavaScript and Python. But fstring, my tool fstr, is kind of more like doing something similar to printf, where you have a string that is just like a normal string, but that has placeholders in it, but then they're named as well. So it kind of draws upon the ideas from these kinds of constructs in programming languages, and from printf. So this is kind of the functionality that brings together. And kind of let me give you some practical examples of where I implemented it in my own command line tools. So basically, kind of this first sentence, by the way, summarizes the whole kind of intention behind this tool. It says here that there are times when a shell script needs to allow the user to set custom string values that may include variable content. So this kind of might not make sense at first, but let me just show you rather than try to like explain it in this abstract way. So I wrote this command line tool called dechapter, which allows you to merge footage from cameras that split long recordings into individual parts called chapters. So for example, GoPro cameras do this. So over here I have a sample folder with some GoPro footage that was split in this way. So this is one recording. You can see that it's named, has this number 3343, but it's split into 5 individual files, and the same goes for this one. So this tool allows you to merge this footage like this. So this will be just do a dry run so that we can see we're only interested in this case in the output file name, because that's where the f string is used in this tool. So I'll press enter, and we'll get a simulation of what this tool would do if we ran this operation for real. So you can see that the files get named like this, and they follow a pattern. So here's one, so this is one file, and this is the second file. So this name got created based on this value of a variable that is set to placeholder name dash merge dot mp4. So this uses f string to accomplish this. So the advantage of having this is because I can give the user an opportunity to define a file name that I don't know a part of yet, that gets computed within the script at a later point, so it can get substituted at some point later, which is what happens here. So this value, we only kind of get to know it once we have found the files and found out the correct like a name to put in here, and then it gets put in place. So I couldn't have created it with fstring. I couldn't have created it with bash. Like at least not like in a safe way. I could do like something with eval, but that would be risky because there is a chance that some code might get run accidentally, and that's not a good solution at all. So, but this doesn't have this problem. So let me just kind of open the man page for dechapter real quick to show you that for this option, let's see, output. So for this option, I have 4 placeholders defined here. So I'm not going to go into what these things do. So like you have a date here that you can put in the file name, for example, and stuff like that. So the point is that it can be very powerful. It gives you a lot of, it gives the user a lot of options to that for defining this value, customizing it to their liking, and so this is kind of a very powerful thing about it. There's another command line tool that I wrote called search and subs, which well, it searches for words and subtitles, as you can probably guess from the name, but it also allows you to play the search results in MPV by using kind of something that's called EDL, edit decision lists, in MPV, that it just creates a virtual video file composed of segments of other video files. So in this case, it just pulls all of the search results that it found into a virtual file, then it can play it to you. So, but in that file, the individual search results become chapters of that virtual video, basically. And so to get the chapter name, I used fstring. So let me see. The default value here is actually an empty string. We won't get into like the reason why that is. There's it's a performance optimization thing partially, but let's take a look at my kind of personal configuration file for this tool. I have here an fstring value set, and you can see that I'm using placeholders here that are called file base and text long, and that allows the chapter name to look the following way. Let me see. So I have a demo folder here, so we should be able to do a quick demonstration. So let's say search and subs. Let's search for texts, and so if I just run it like this, it gives me all these search results. But then I can also pass the -p option to it, and that will play it in MPV player.
Bilder, det kan vara texter.
So here we go. It's playing the video, and you can see that it has several chapters. And I have a scroll on the seek bar. I can see the chapters names, and I can also press F10 to see the chapters list, and you can see that it's substituted the file name where the search result came from, and also it inserted the contents of the subtitle that matched. So this is another use case for this, kind of similar to dechapter, but in a different context. So I can open the man page for search and subs and show you real quick as well the kind of the list of placeholders that are possible to use in this chapter title setting, and there's quite a lot of them here. So it gives you again like a lot of customization options. So this is really good. And yeah, so these are kind of the use cases for this, and hopefully this gave you a good idea of kind of why I wrote this tool. So now let's see. Let's talk more about the different functionality that fstring has, because it has it can do more things, like I said, that I haven't mentioned yet. So let's open the man page for fstring and take a look here. So we've already covered the basic usage. So the format string, or like I don't call it the format string, I call just string with placeholders. And then it's followed by name replacement, repeated as many times as needed. So that's its like synopsis basically. And then over here in this section, these individual things are explained. And under string, we can see the placeholder format being described. So we saw that the name can be just percent sign and then the name follows that directly, or the name can be enclosed in curly braces, in which case you can have a fallback, and you can also have an override, which I haven't shown you yet. We'll get to this in a moment. So, and then fallback and override are optional, so you don't have to have them. You can just have name in curly braces and that's it. But you can also have fallback and or override, and in any order. So you can put override first and then fallback second. It doesn't matter. And you can see like the syntax for this is a colon minus for fallback and colon plus for override. So if you're familiar with bash scripting, this will be pretty will make sense to you probably when you see it, because in bash there's these parameter expansions that kind of do similar things, colon minus and colon plus. So let's take a look at in more detail. Let's take a more detailed look at these fallback and override things and what they can do. So we've already seen the fallback in action. So let's now take a look at override. So override will just always use this value that is provided here if the substitution succeeds. So you might kind of think this, well, why is this useful? So it will just always substitute Fox no matter what you pass here. Well, there's kind of different circumstances where it could potentially be useful. The primary one that I was kind of the reason why I wanted to have this, really wanted to have this functionality here, is because sometimes you might want to have characters inserted next to your substitution, but only when the substitution succeeds. And here's like the cool part about this tool, which I really I'm quite proud of this, because the override and the fallback can themselves be strings with placeholders. So this whole thing is recursive, and so this way I can use the animal placeholder here again, and then I can add something next to it, and that will basically, let's just put something here like jumped over the lazy dog. So in this case, if there is something to substitute, it will substitute animal placeholder jumped over the lazy dog. So if I press enter now, we get the quick brown rabbit jumped over the lazy dog. So this is kind of like a bit of not exactly the kind of example that I had in mind when I was writing it, but it demonstrates what this can do. Usually you might want to have like a space here, for example. Maybe there's something like or like a dash or something like that. Maybe it's like a file name or something, and you only have to like you only want this dash to be here if there is like a substitution. So for example, I don't know, stuff.txt. So maybe you want to have this file called stuff.txt, but if there's this like animal here, then you want to have it called animal-stuff.txt. So this will give you rabbit-stuff.txt. But if you don't have this defined, so the way that it's implemented currently is that it will give you an error if it can't if there is no fallback defined and the value is not set in the arguments. So for this kind of to work, you need to also set the fallback. So I don't know, maybe there is something to improve here, but I'm not quite sure at this time. But like right now, it's implemented like this. But the point is that you can see that you can set a string like this with kind of a conditional segment, which will only get which will get substituted and formatted in a certain way if a value is set. So that's the intention behind the override. So let's see, let's take a look at the man page again. So yeah, you can see here that I say that override is substituted instead of replacement, allowing to, for instance, insert extra characters next to replacement. So that was kind of the original intention behind this. Now, to keep this video short, I'm not gonna go into escaping here, but escaping is done with backslashes. So the backslash, the %sign, the curly braces, and the colon are special characters, and if you want to use them in a string with placeholders, then you need to escape them with backslashes. And we have three things that can be strings with placeholders. It's the str, which is just this first argument that you pass to fstring, and then there's also the fallback and override, which are also strings with placeholders because the whole thing is recursive. So let's take a look at an example of how you would use fstring in a shell script. So over here I have search and subs open, and you can see that fstring is used over here, and I pass to it what is essentially an associative array. So how would you pass associative arrays in Bash? Because that's not something that you can do. You can't like pass an array to anything really. You only work with the values. So you have to extract the values from an array to pass them to any command. So there is luckily a solution for that in Bash. So there's luckily a solution for this. So there's luckily a solution for this in Bash, which I haven't seen talked about a lot. I did make a video about this though. So let's see, let's find the thing that we need in the manual. So here we go. There is this syntax. You follow a variable name or an array by @ and then you use one of these letters to do certain things. And in this case, we're interested in the capital K, which produces a possibly quoted version of the value of parameter, except that it prints the values of indexed and associative arrays as a sequence of quoted key value pairs. So this is exactly what we need. I made a video about this functionality in Bash, by the way, which is this video, and I'll link it in the description below. So let's take a look at how this parameter at K works. So you can see that is what I use over here, and I also use eval, which might kind of sort of like be a bit sort of like, is that really safe here? But it actually is, because precisely because of this dash or this at K functionality. So let's just create an example here. Let's create an associative array. I'll call it just A, and let's just make up some stuff. Doesn't really matter what the values are here. So this is what it's gonna be. Let's test that it's properly declared. So yeah, now let's do like echo A. So we'll pass the entire array to echo, and we'll do at capital K. And so you can see that what happens here is that it outputs all of the keys followed by their respective values, and so in a quoted form. And this is crucial because they're quoted. So let's actually like add another value to this array that will be kind of that will have to be quoted. Let's just create actually something like kind of a bit that maybe this is a command like let's call it dangerous command. So if that code was run, then you might get problems. So let's see, and now let's run this @k thing again, and we see that the string is quoted, so it's safe. It's going to be just these literal characters, and that code will not be run. So this is why I'm using eval here, because this is in fact safe to do. So so yeah, I just have this array here basically with all of the placeholder names as keys. So you can see that if I open the man page for search and subs and find the section for this that lists all the placeholders, you can see that these are the exact same values that I have over here in this array. The keys are the placeholder names. So, and then the values are the values that the script computes, and then they're ready to be substituted. So at this point, I have this command substitution, which basically it kind of like I need to get the final string, which is gets assigned to this variable chapter title, and so let's see how this bit works. So let's kind of do something similar with our example. So we have this right now. So let's use a subshell here because I'm going to be using set. So set sets the positional arguments of that particular subshell. So for example, I can use set run set like this with the arguments 1, 2, 3, and if I take a look at the positional arguments, we can see that they were set to 1, 2, and 3. So that is what set does. But we can also pass to it all of our values that we've created, but this actually will not work, because if I just kind of run this with echo like this first, this is what it's gonna get, but it will get basically this entire thing as one string. It will just set this to argument, positional argument 1 if I run this. Let's just gonna do it to take a look at that to prove it. So just like if I do echo $1, we can see that the entire string was assigned to that. So that's not what we're after. But luckily, we can use eval with this, because we've safeguarded, we've quoted the entire thing. Or not, I say we, like Bash did it. So like Bash has this built-in way of quoting an entire array. It can also be an indexed array. In our case, we're using an associative array. So it's quoted, it's safe, so we can use eval with it, and we can do it like this: eval set dash dash, and then pass the entire thing. So I could actually like even quote it like this. It would be the same, but eval just kind of concatenates all of its arguments separated by spaces, and then evaluates the entire result. But we can do it like this as well. It's kind of a bit maybe easier to read or something like that. So if I press enter now, we can see that our results, even the dangerous command, got assigned to echo or to the positional arguments. There's actually a better way to view positional arguments. So just a little aside here. There's also this q operator here, which is very, very handy. It just basically quotes. It can quote either the entire array or the string that is assigned to that variable. So in this case, we have all the positional arguments, and we can just use put everything in the curly braces, and use @q to quote everything. That way we can clearly see all of the arguments here, because we have spaces here and it's not clear what is what. But this way it's quoted, and it's unambiguous. So even if I had like let's add something like really weird here again, like let's add EEE equals, and let's just put something like 7 all clock so that we have an apostrophe here or a single quote. So now if we run this thing, we have this string correctly quoted here. I just did this just to show that this is very handy because it quotes everything unambiguously, and what you see is the correct shell quoting automatically. You get it by using @q. So that was just an aside about @q, but we were really interested here in the output of how eval is used here with set and with the @k operator that is acting on an associative array. So I hope this whole example made sense, and now maybe this code makes a bit more sense to you as well, because this does the exact same thing. It takes this subtitle data associative array, does the @k on it, and then it's run through eval set dash dash, then all of that. And then we have all this stuff set to the positional arguments of this subshell, because this is a subshell. So it has its own set of positional arguments that is separate from the positional arguments of the entire script. And I can use set here. I don't need to like create an array for this. There is already a kind of this array of positional arguments, so I can just use that here. And then I just use fstr, pass my string with placeholders, and then I just pass $@, so that pass all of the positional arguments which were already correctly assigned here. And so we can play further with our example. Now we can use fstr here. So basically we'll do the same as search and subs does. So let's just kind of clean this up a little bit so that we are not lost in all of this mess. So this is our array, and this is our thing. So right now my string of placeholders is empty, but I can use a placeholder here. Let's use AAA. I get 1. Let's use like EEE, 7 o'clock. So everything is working. So this is how you can implement it in a use it in a shell script. So one other thing that I wanted to mention here is how you can embed this tool into a shell script. So you can see that I have a function here in search and subs that is called fstr, and then it has all of this Lua code here. So the fstr itself is written in Lua. It's actually a Lua script, but what I provide in the repository, in addition to the script itself, so this is the script. It's written in Lua, but there's also some additional tools here that are available. So first of all, there's a shell wrapper that you can symlink to your to a directory on your path so that you have it available as a normal command line tool. You might sort of wonder why I did a shell wrapper instead of just kind of doing a Lua script and putting a shebang line pointing to a Lua executable. The reason is because sometimes Lua executables are named in kind of unpredictable ways. So for example, I'm on Debian, and if you install Lua from Debian repositories, depending on the version, it might be called, for example, 5.4, right? Like currently I have Lua 5.1 on my system and 5.4. And there's really no way to like get around this other than to write some kind of check like this that goes through them one by one and checks like, oh, if there's Lua 5.4, use that, otherwise use Lua. So I couldn't do that with a shebang line, and so that's why I did a shell wrapper. And then in addition to this small shell wrapper script, I also have this generate bash function script, which allows you to get that bash function that I showed you that I have here in the search and subs. So that simply parses the fstr.lua file, and it gives you that function. So if I run tools, let's see, tools generate bash function, it outputs that. So it basically just kind of inserts that code in here, and it also like does some adjustments to quoting so that everything is quoted correctly. So these are some of the the tools that are available with fstring. So this is it. I hope you found this video interesting, and I hope you liked this new tool. I certainly found that having this available allows me to do more things when I write command line tools in Bash, and I hope that you find this tool valuable as well. So this is it. I hope you liked this video. If you would like to support this channel, you can do it at ko-fi.com/linguisticmind. Thanks for watching, and I'll see you in the next one.